To be a science superstar, you also have to be a safety superstar. We're really focused at Champion Science Adventures on making sure that these hands-on engaging activities with lots of different materials and a lot of activity with the children moving around are as safe as they can possibly be. We're going to call out science safety tips in the lesson, but there are some general guidelines which we're going to go into here. Now, the lesson that I'm going to use to illustrate this is one of our chemistry lessons, because ultimately chemistry lessons are fraught with some challenges. You scream, I scream, we all scream for slime. That's the lesson we're going to do today. We're going to actually make some racing slime. It's one of the lessons that is part of the program, and by doing it we're going to actually go through step by step some of the things to pay attention to make sure you have as safe as a classroom as possible. To make our slime, we need chemicals. Every single one of our chemical lessons, really the best practice is to pour the chemicals before the children arrive in the room. This allows you time to make sure you're not doing it in a hurried and fast way with spills. Also allows you to get the quantities correct. For racing slime, we need two chemicals. We need polyvinyl alcohol and sodium borate. Every single chemical we use in our lessons are safe. We're not using anything that's toxic or anything that's caustic. Chemicals are either non-toxic, not food, or they're actually food, things like vinegar and baking soda. So we're using really low-level chemicals, but best practices, you always want to train and sort of teach the children respect for the chemicals, and we'll go over the chemical safety rules in a little bit. So I'm getting ready to teach my class. I'm going to go ahead and pour my chemicals. I've read the lesson. I know I need 3/4 of an ounce of polyvinyl alcohol, and if I was teaching a set of classrooms, I'd have a line of cups, and I'd go ahead and pour one for each child. In this case, there's only one child in the room. That's me, so I'm making one set. I know I need 1/8 of an ounce of sodium borate, so I'm going to pour in 1/8 of an ounce. Now you can tell I have been really rigorous in my measurements. No, I've eyeballed it. Our lessons are designed to be really easy to implement. The measurements we give you, it's good enough just to eyeball using your eyeballs. And make sure you're just getting approximate. It will still work. Nothing is really critical. We're not talking about milliliters here and any of that kind of criticality. Next, once you've poured the chemicals, I usually like to put them on the lids of boxes to use them as kind of trays, or if you have trays, you want them out of the way. You don't want them on the table when the children get into the room because they'll play with them, they'll knock them over, they'll generally make you not happy and make the lesson unsafe. So I've gone ahead, let's pretend I've got 20 of PVAs and 20 of sodium borates. I've prepped and I'm ready to start teaching the lesson. So the children are in the room. I've actively engaged them with some really interesting questions about racing slime. We've started the activity. We're going to start our explore and experiment. I'm going to introduce the children to the 3 laws of chemistry, or the 3 rules of chemistry in my classroom, and these are listed in the lesson. Rule number 1, we're not going to eat or drink anything, and that's a good rule for any science classroom. Nothing goes in the mouth. Rule number 2, we're not going to stick our noses, our hair, our neighbor's hair into the chemicals. And rule number 3, we're going to listen to and follow directions. That's really important. Whenever you do chemistry with children, they always think if you don't follow directions, it will blow up. No, the only thing we blow up in Champion Science Adventures are balloons. None of the activities are going to blow up. In fact, if you don't listen to the direction, the only result is it probably won't work. So to make slime, I'm going to go out and I'm going to hand out the 2 chemicals each child will need. I will tell the children not to touch them until I give them directions, and I'll just put them down quietly in front of them. If you're working with younger children, you may want to put a paper towel down on the desk. So if they do spill anything, it's not a huge mess. We're going to hand out the rest of the equipment. In this particular case, it's going to be a cup with a stick in it. And I'm going to instruct the children to pour the cup that's full into the empty paper cup. In Champion Science Adventures, pouring takes 2 hands. One hand holds the cup you're pouring in, the other hand does the pouring. Once the children have done that, I'm going to come around with glitter. Like glitter, like any sort of powders, you want to be aware if there's any strong winds or if you've got fans on. We don't want this blowing in children's eyes. It would be a horrible irritant and upsetting to them, so please be aware of that. And you're going to go ahead and the reason for that dust factor is usually any dust in a lesson or anything that's really fine, we're going to have the teacher distribute. And you just go around, you can share some of the fun facts from the big idea section. You're going to go around and sprinkle in some glitter into each of the children's cups, and the children are going to stir. Guess what? Stirring takes 1, 2 hands. One hand holds the cup you're stirring, the other one actually does the stirring, and the children are going to stir in the glitter until it is all glittery. Technical science term. We are now ready to make our slime. We have our starting ingredients, polyvinyl alcohol with the glitter, and this lesson really teaches about polymers and all that information about polymers and long chains of molecules and how they hold hands and how they tangle together to make slime is included in the lesson plan for you to teach the children as part of What's the Science. We're going to go ahead and pour in our final ingredient, the sodium borate. How many hands do you think that's going to take? You, sir, correct. You in the back. That's right, 2 hands. One hand holds the cup, the other hand does the pouring. Children are going to stir using 2 hands. And as if by magic, the slime will form and we will end up with ooey gooey glitter slime. And the children have made their very own slime. Is it food? No, it's non-toxic, but it's not food. So you're always going to caution the children not to taste or not to eat what they've given. And when they take this home, you want to caution them that they need to share that. If they've got younger brothers or sisters, they need to keep it out of the way of the younger brothers or sisters. It is totally safe to touch, and the children are encouraged to touch it. It's an inquiry-based lesson after all, and you just make sure they wash their hands afterwards, and you want to make sure they don't spill any on the floor because it will be slippy, and any spills should be cleaned up immediately. So they've gone ahead, they've made their slime in this particular lesson, they're going to take it home, they're going to put it in their own little cup. They'll actually do some investigations with it as slime to sort of explore that polymer science. And we include a nice little sticker that goes on the cup. This tells mom about the chemicals. It says racing slime, non-toxic, non-edible. If you eat it, it won't kill you, but you shouldn't eat it, basically. So there you go, the children have made slime. We followed some chemical safety rules. The second part to this lesson, it has them actually racing their slime against some food ingredients. And they're actually going to race their slime, and they're looking at viscosity, and they're going to race it against mustard, mayonnaise, and ketchup. Some of our lessons actually have food ingredients. At all times, whenever we have food in the lessons, I'm always cautioning the children it's not food to eat, it's food to do science with. We never want anything going in our mouths in science because we just don't want to set that kind of criteria. Nothing in a science lesson should go in the children's mouths. This is not to eat, this is to race. This is racing mayonnaise and racing ketchup, not eating mayonnaise and eating ketchup. And children are going to come together in groups, and they're actually going to look at viscosity, and they're going to race their different condiments out of the packets down against the slime and see which liquid is, or semi-solid is more viscous. Whenever you're doing group activities, or you're transitioning to outside for a flight lesson, or you're having children get up to go get supplies, you always want to make sure you're paying attention to that movement. You want to make sure you're got the same number of children that you started with, that you end with. You want to make sure people are walking, not running, and moving in an orderly fashion. That's another safety thing to bear in mind. Bottom line is, pay attention to your class. This is an active kinesthetic type activities. Children should be moving around, they should be engaged with each other. It's not a silent activity that takes part behind the desks, but to facilitate that in a way that's really healthy for the entire group, you need to make sure that you're paying attention to safety and you're looking for potential trips, slips, falls, and bangs, because we don't want any of that to happen. So thanks.